Hello students, I hope that you are good, well and fine. Today we will be seeing the subtopic of maxima and minima in applications of derivatives. Okay, so let's see what do we mean by maxima and minima and how it will benefit us. Okay, so maxima and minima. In this section, we will see the use of concept of derivatives to calculate the maximum and the minimum value of various functions. Okay, in fact, we will get help to find the turning points of the graph of a function and thus find points at which the graph reaches its maximum or the highest, or you can say the lowest value locally. Okay, you will also know why we are saying locally. Okay, the knowledge of such points is very useful in sketching graph of a given function with a okay. So if you know that how highest my graph can reach, then you can have some idea that how my graph will look like. Okay, or you can have some idea about that my range is in between this part. Okay, so all this maxima and minima gives you the best condition for range also. Okay, further we will also find the absolute maxima and absolute minima of a function that are necessary for the solution of many applied problems. You will see all. Okay, let's see. So let us consider the following problem that arises in a day-to-day life. Okay, day-to-day life. First, the profit from a grove of orange tree is given by this, where AB are some constants and X is the number of orange trees per acre. Okay, how many trees per acre will maximize the profit? Okay, and second, that a ball thrown into the air from a building of 60-meter height travels along a path given by this, where x is the horizontal distance from the building, hx is the height of the ball. What is the maximum height of the ball will reach? Okay, you will see, or you can answer such type of question according if you know the concept of maxima and minima. And third, also the Apache helicopter of enemy is flying along the path given by the curve. This, a soldier placed at the point 1, 2 wants to shoot the helicopter. When it reaches the nearest to him, what is the nearest distance? In each of the above problem, there is something common. What common? That we wish to find the maxima, either maxima or minima thing. Yes. Okay, so in order to tackle such problems, you will be able to answer these three problems if you get familiar with what the maxima and minima thing. Okay, so let's jump to this topic. So definition. Okay, after getting familiar with, please try these three problems given at first. Okay, this will reflect you that now you have this much of understanding of this topic, maxima and minima. Okay, so here we have to define our function f on interval I. So then a f is said to be a maximum value in I if there exists a point C in I such that f of C is strictly greater than f of x, where x is any value from the interval I. Okay, clear? The number fc we will be calling it as what? Maximum value of f. This will only happen when there exists a c in the given interval, and that c, the output of f, will be the highest output. Okay, there will be no any other value inside the interval such that fx attains the maximum value. Okay, clear? Okay, so this point C, we will be calling it as a point of maximum value of f in the interval I. I hope it is clear to you. When do we say C is a point of maximum value of f? We say when this condition satisfies that C must belongs to, first thing, that C must belongs to the interval, then f of C must be greater than f of x, where x is for every x, where x is any value from the given interval I. Okay, then only you can say that fc will be your maximum value and C will be the point where you attain your maximum. Clear? Okay. Now, f is said to have minimum value. When do we say that f have a minimum value? When there exists point C. So C must be in this interval I such that f of C will be less than fx, where fx is the output at every or at any x inside the interval. Okay, this means fc, this output will be the least output from the range of this as your domain. Okay, if this is your domain, then fx will be having some range, then this range must have some minimum value. Okay, clear? Then you will say that this value will be your minimum and fc will be your minimum value, and the point at which we attain our minima, you will see that point as point of minimum value of f in I. Okay, clear? Okay, now see, f is said to have an extreme value. Now we are talking about extreme value in I if there exists a point C, in I such that, okay, fc is either maximum or a minimum. If someone is saying that f is having extreme value, it could be maximum or it could be minimum value of f. Okay, it is not clear at this stage that we are talking about minimum or maximum. If someone just refers to this term, this means either he can be talking about or she can be talking about the minimum value or talking about the maximum value. Okay, so the number fc, in this case we will be calling it as an extreme value of f in I, and C will be what? C will be an extreme point. Okay, clear? Okay, let us move next. I hope that these definitions, these three main points are very clear to you. Okay, let me just once again go through them. So, maximum means, as the name suggests, maximum means it will be the highest or the greatest value we are talking about. And greatest in what context? Greatest in this interval. Okay, when we talk about maximum value, this means we will be talking about some interval. Suppose we are talking about in this interval I, then first of all, there exists C inside this. So, C must be existed inside this interval and f of C must be greater than f of x, where x can be any value. Okay, this means for every x, fc must be greater. Then you can say your f attains maximum. The same thing will happen for minimum, but the only thing here is that f of c will be now less than f of x for every x in the interval. That's it. And when we talk about extreme value means it is not yet clear that we are talking about maximum or minimum. It can be, okay, it is not clear. So when someone says or refers to this term, this means he or she is trying to say that either he attains maximum or minima. Okay, the more information we needed. Okay, clear? I hope that it is clear to you. Let us move to next now. Now, if you try to see figure 6.7, this A shows what? A, B, C, three graphs we are having. Okay, we exhibited that graph of certain particular function help us to find maximum value and minimum value at a point A. Okay, Now, in fact, through graphs, we can even find maximum minimum value of a function at a point which is not even differentiable. Okay, clear? So, as you can see, the highest point is this. Yes, the highest point is this, which is f of c. Okay, here you can see the highest point will be f of 4. The minimum point will be f of 1. Okay, clear? As you can see, the minimum point will be this f of c. The highest is not given yet. As it can grow, it is a parabolic type graph. So I think this is going to be forever. Okay, the same will happen for this. You cannot find the least value. But here, as you can see, your graph is just in between 1 to 4. Okay, the domain in domain 1 to 4. So you are getting your minimum and you are getting your maximum value. Okay, so the graph also helps us in finding a maximum or minimum value. So if someone asks that what is your maximum or minimum value of this function fx is equals to x square and where x belongs to real number. So if you look at your graph your graph is parabolic, and as you increases towards plus infinity, as you reaches plus infinity, the graph also reaches plus infinity at y-axis. If you reaches to minus infinity at x-axis, then your graph will reaches towards plus infinity as y-axis, on y-axis. Okay, clear? So this means you cannot get the maximum value. So there does not exist the maximum value. Okay, but there do exist your minimum value, and minimum value is at 0. So f of 0 will be your minimum value and this will be just 0. So minimum value of your function will be 0. Okay, simple. By just looking at your graph you will get your answer. Clear? Okay. Now if you talk about restriction, if we restrict the domain from -2 to 1, okay, let's see, then your graph will be somewhat like this. Okay, so this will be what, your -2 point. The output at -2, you will know the leftmost point will be what, this will be at -2, this point will be f of -2. Yes, which is what, this point will be just 4, as you can see, and the rightmost point will be this is your 1 means this point will be 1 comma f of 1, this means 1. Okay, as your fx is just nothing but x square. Okay, fx is just nothing but fx is equals to just x square. Okay, so far so good. So you can easily see the maximum. If you are talking in context of this domain or in this interval, closed interval -2 to 1, then you can see that there exists a point. So -2 belongs to what interval? -2 belongs to -2 to 1. Yes, and f of -2 is greater than f of x for every x belongs to what interval? -2 to 1, as you can verify. So this means this will be your maximum value. The maximum value will be f of -2, which is just 4. Okay, so your maximum value will be at -2 and it will be 4. Clear? Now if you want to find the minimum value remains the same, the 0. It will be 0, 0, 0. Okay, I hope that it is clear. So it is totally depending on the interval we are taking. Okay, so whatever the function you are given with, please do be careful with your interval, the interval in which we are talking about. Okay, let us move next. I hope that it is clear to you. Okay, so without your interval, we cannot have clear idea about maximum or minimum. Okay, if it is not clear about what domain we are taking, then it will be very difficult to answer that in what context we have to find the maxima or minimum. Okay, now suppose here, what about the maximum value? As you can see, this, if you are talking about the domain is whole R, then you can easily know that this moves like this and this part of the graph moves like this. So you cannot have the maximum value, no maximum value. So no maximum. Okay, so no maximum. But what about minima? Yes, minima will be this point 0. Minima will be this point 0. So your minimum value, f of 0. Clear? As from graph, you can easily say that. Okay, I hope that it is clear. Okay, if you restrict your graph, suppose you restricted your graph from -1 to 2, then what will be your maximum value? Then maximum value will be your just 2. Then maximum value will be your 2. Okay, clear? Okay, I hope that it is clear. Okay, so it is totally depending on what restriction or what domain we are talking about. Okay, in what domain, in what interval, okay, and in what restriction we are talking about, then only we can answer maxima and minima things accurately. Okay, let us move next. Now here you have to find the maximum and minimum value if any of the function. Okay, so this function is given fx is equals to x in this domain open interval 0 to 1. Okay, open interval 0 to 1. So one thing is very clear. If you try to look at by graph, okay, just look at it by graph. So you are taking open interval. Be careful with the graph. Okay, so open interval, you are taking out open interval 0 to 1. Okay, your graph will be what? As you know, it is open interval, so your graph will look like this. Yes, your graph will look like this, and this point will be 1. Yes, okay, so far so good. If you try to see what will be your range, range is what? The same thing. Range is also same. The domain is same, the range is same. Range will be this interval. Range will also be the same. Okay, as you can see, it is just what function? Fx is equals to x. Whatever the input you give, the output will be the same as input. Okay. Okay. Now the range is same. Okay, so far so good. Now if you try to, if someone were asked about this, that what is the maximum value? So just do not blindly say that the maximum value is f of 1. No, maximum value is not 1. And do not blindly say that minimum value is 0. No, it is not. Try to recall the definition. What definition is trying to say? The definition is trying to say that, first of all, if you are saying that it exists maximum value, so why I am saying no maxima and no minimum value is there? Why I am saying that? By graph, it seems like that the graph is totally in between 0 to 1. The range is in between 0 to 1, but I am saying that it doesn't having any maxima or minima. Why? Because the definition says that. Definition says that if you are having maximum value, this means your C must be in this interval. Okay, that C must belongs to open interval 0 to 1, and this means f of C must be greater than f of x for every x belongs to 0 to 1. This must happen. Okay. So you now what I am saying that this cannot happen. So this means I have to neglect this point. Okay. So take any point. Okay, say take any point from this interval. Take any point. Okay. Suppose I took x naught is equals to from this interval. Okay. So x naught is from in this interval. Clear? I know what that x naught. Clear? X naught belongs to this interval. I am saying that we cannot have the maximum value. Okay. So what you will do, so x naught plus 1 divided by 2. This will be what? As x naught belongs to this interval, this means x naught plus 1 belongs to what interval? 1 to 2. Yes, 1 to 2. As you can see, x naught is less than 1 but greater than 0. If you add 1 to both sides, what you will get? This. Divide by 2 both sides, what you will get? This. So this means this will also going to belongs to in this interval, as you can see. Okay. Now what? But one thing is very clear. But one thing is very clear, that x for every x naught, for every x naught in this interval, you will have what? So as you can see, x naught is less than x naught plus 1. Okay, x naught plus 1. Simple. Now what I'm trying to say that is, whenever you have any number x naught, whenever you have any number x naught, okay, whenever you have any number x naught, then what is happening? As you can see, this x naught will be less than x naught plus 1. Okay, so far so good. Now what I am trying to say is that this x naught will be less than this. X naught by 2 is less than this thing. Yes, x naught will be less than this thing for every x naught belongs to 0 to 1. Yes, and then what will happen? Okay, and then what will happen? If you try to see that, this will happen that okay, clear? This means if you divide by 2, okay, if you divide by 2, okay, let me just be clear. Okay, so this I am going to take. Now what will happen is that if x naught is very close to 1, if x naught is somewhere here, okay, x naught belongs to in this interval and it is somewhere here, very close to 1. It is very close to 1, then what will happen? Then this x naught plus 1 by 2, this will happen that this also going to belongs to this interval, I have already told you, and this x naught plus 1 by 2 is all greater than this thing. So whenever you have any point near to 1, this will always going to happen. This means you will always be having some point which is greater than that. Okay, so that's why you cannot say there exists C such that f of C is greater than f of x. You cannot say that. Okay, if you pick any point near 1, then pick any x naught near 1, then this will happen. This will also going to belong to the same interval, but this point will be greater than this. I hope that it is clear. Okay, I hope that it is clear to you. Simple? Okay. So this means you cannot have maximum value. Now what about minimum value? So for minimum value, if C is very near to 0, then I have to show this. Yes, so this means C is very near to 0. So pick any C, then what you will do? You will do that C by 2. This C by 2 also going to belongs to this interval, yes. So this means this C by 2 will be what? This C by 2 will be less than C. This C by 2 will be less than C. So pick any value near 0. Pick any value near 0. Pick any value near 0. Always half it. And this means you cannot have such C such that this will happen. Okay. Pick any C. Pick any C near 0. Pick any C near 0. Then what will happen? You will always have C less than that point such that f of what is happening? Such that f of C, okay, such that what is happening, that f of C by 2 will be less than that C. So there does not exist any C. If you are saying that there exists C such that this will happen, and you just saw, pick any C belonging to near 0. This means taking C by 2 will be what? Also going to be in this interval, and from this you can say that C by 2 is less than C. Yes. So this means there always exists some point which is going to lesser in value, in quantity. That's why it cannot happen. Not always, not for every time. Okay. I hope that it is clear. Okay. So I hope that it is clear to you. Okay. Now let us move next. Now, every monotonic function assumes its maximum minimum value at the end. Okay, at the end points of the domain of definition of the function. So what it means? If my function is monotonic means increasing or decreasing. Okay, then it assumes maximum or minimum at the end points of the domain of definition of the function. Okay, clear? If you are having either increasing function, then at the end points of the domain you will find out that your function is going to be attaining maximum or minimum point at end. Okay, and in the second point says that every continuous function on a closed interval has maximum as well as a minimum. If you are having continuous function and it is defined on what? Closed interval, then it will be having maximum at the what? Somewhere in the closed interval and having minimum somewhere in the closed interval. Okay. Clear? Okay. So note, by a monotonic function f in an interval I, we mean f is either increasing or decreasing. That's what I already told you. So monotonic means either increasing or decreasing. We are talking about either increasing or decreasing. So that's it for now. Okay. So I hope that you understood every concept we showed you. Okay. Everything is clear. Every definition is clear. Main important thing is that the definition of maxima and minima must be clear, and also the example, please give more your thoughts on the example we discussed. What example we are talking about? I'm talking about this example. Please analyze it carefully. Okay, clear? Give your thoughts. Okay, so that's it for now. So we will be back with the questions, some extra examples from this subtopic of maxima and minima. Okay, so thank you.